So I'm the founder of DeSci London. DeSci London is 2 years old. It's the largest in-person DeSci community, and we have over 700 members. This June is our 2-year anniversary. So we've been going on for 2 years, and the problem I now had was, okay, I helped start up a community, but what are they actually doing? Because meetups, conferences, they're good to collaborate, they're good to meet people, but was this actually pushing the needle forward? So what this talk is about is there are a number of problems. If we think the thesis is correct that DeSci is going to advance the space forward, that DeSci is the scientific revolution, one of the biggest problems is that there are very few spaces in the world where Web3 developers and scientists have prolonged, repeated interactions. Meetups aren't enough, conferences aren't enough because that's just for a few hours. You need a dedicated time and space where these two people can meet, cross-pollinate ideas, and brainstorm, iterate on things, and then finally find out a solution of how they can apply the Web3 tech into science. So this is what MuseMatrix is aiming to do. So it's a 6-month program. It's 2 months of teaching, so we've got a curriculum of a variety of topics covering both the basics of science, so very foundational scientific concepts, to the basics of Web3 and DeSci, and then it's 4 months on hacking. We've got a very strong focus on cognitive diversity, so we want a variety of people, whether that's biologists, chemists, physics, AI, ZK. I name all of those because we have those already signed up for our fellowship. That's a bit more. So yeah, we launched this 2 months ago. We had a lot of applications. We've got 40 people confirmed to be in this fellowship, and actually starts on Friday, which is one of the reasons I need to head back and not stay in Croatia for that long. And I'm going to give you a brief overview for how we're planning on running it. So the teaching phase is peer-to-peer learning. I was not a very good student at attending lectures. I find lectures very boring. I do not like sitting, receiving information. I've always found the things that I learnt and retained were things that were self-directed. So that's the strong component. It's self-directed peer-to-peer learning in a social setting. And if we get time, I can give you a bit more explanation for how that works. And how we as MuseMatrix, the core team, are thinking about this is we want to try to productize everything we do. So the first thing that we're going to productize is this peer-to-peer attestation framework for how you can learn. And I hope I've got time to go into it because I've got a few more slides, but let me go into the next phase. Then it's the building phase. And this was one of the key differences in what we wanted to do was I've taken part in other incubators, accelerators, etc. And often what you get is like 20, 30 projects, and then by the end of the year, none of them exist. And that was one thing I wanted to avoid. So the plan here is for 40 people to work collaboratively on one project for 4 months. And in that way, we should be able to execute and get some traction. The building phase starts in 2 months, so we've got 2 months to decide what these 40 people should work on. And this is going to be open to the community. So we're going to be hosting a bunch of Twitter spaces. Some of the DeSci London meetups will be involved. And if anyone here has got any ideas of what these 40 fairly talented people should work on, and just to give a quick overview of background of these 40 people, like I mentioned, we've got a physicist, we've got 2 chemistry people, we've got like a longevity person, neurotech, AI, ZK, and these people don't really hang around. And they've committed to building something over the next 6 months. I have an idea of what I want them to build, and I will share this shortly. But if anyone's got a suggestion, please reach out to me. We want this to be a community-driven effort into deciding what they work on. These are our focus areas, mainly because this is where capital is available. We're not necessarily limited to it. Like I said, we've got chemistry people, physics people, but generally, these are the things that are getting traction in biotech. Quick overview of the curriculum. I don't think we need to spend too long on that. Partners and supporters. Yeah, we've got a bunch of mentors. That's the other way that anyone here can get involved. We are still looking for a range of mentors, so if anyone feels that they are not able to commit anything for a long time, but they could do, say, a 1-hour Zoom call session with some of the fellows, please reach out to me. So this was one of the main slides here. We will be running a second cohort probably in about 3 months, so if people do want to take part, that will be a remote one. If anyone wants to sign up to be a mentor, or more importantly, if we want to run an in-person one here in Croatia, in Split, I think this would be a good outcome from this conference. Any questions, by the way, so far? Nope. Cool. I'll go briefly into the teaching product that we're going to be building and why this product even makes sense. So this is a way of demonstrating proof of learning. So education in general is a massive problem. It's a pre-digital model when knowledge was physically housed somewhere. You used to have to go there. Now, internet, etc., it doesn't really make any sense. 93% of the world don't even have a degree. So the current system of education isn't really suited to the adapting world. Now, one of the biggest problems is how can you have decentralized education in science? Because in computer science, it makes sense. If I'm hiring someone, the only proof I need is their GitHub profile. I don't care if they've gone to university. If I see a 5-year-old GitHub account with multiple commits, I know that that is a reasonable demonstration that they have learned and they've progressed. So that I can use that in lieu of a degree. And in fact, a lot of the big kind of Apple, etc., they don't require you to have a university degree anymore. They just need proof of your learning. So how do you demonstrate proof of learning in science? Anyone wants to shout anything out? Yeah, so, and that's difficult because, it takes months to write a paper and then maybe no one accepts it. Maybe you could publish it in an open source thing. But, if you're just starting out and it's your first 6 months, it's a bit much to require someone to write a paper. Whereas in computer science, it's very easy because your output is code. And that's easy to do from day one of you learning code. Any other ideas how you could do this? Well, I've got an idea. So it involves this peer-to-peer learning with, I think there's an image that might, yeah. So this is the structure, and you guys tell me if you think this is a sufficient demonstration. So there are 10 people in a group. You stay in a small group for this learning. Everyone gets handed one learning objective. So an example could be, what is blockchain? They spend that week researching what is blockchain. They produce like a 2-page written document and a 5-minute presentation to the other 9 people in their group. And then the fellow 2 does that, fellow 3 does that, and then everyone attests to each other that they A, turned up, that they submitted some written work, and B, that they gave a presentation. Then the facilitator attests that the same thing, and the facilitator is more on the quality and content of the work. So this is like an on-chain digital apprenticeship model. And if you do this for 5, 10, 20 weeks, you've got proof of everything that you've learned attested to by multiple people. So the thought experiment here is, would you trust a doctor that had their medical degree via one of these mechanisms? Yes or no? Because, if they've got, signed off by 20 heart doctors that they've got sufficient knowledge, 20 other doctors that have got sufficient knowledge, then over time they've built up an attestation thing of hundreds of doctors signing them off on something. That's as sufficient as a medical degree. What do you guys think? Because? Correct. Yeah, but then they will be signing that on-chain, and that attestation is there for life. So if they later found out that you've got no skills, then you can go back to them saying, look, you signed this guy off, why did you do that? And sure, for the Western world, this is probably unlikely because you need licenses, blah, 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 but to develop a scalable education system outside of the West, this could be useful. And I'm only mentioning the idea of a doctor because if you can safely do that, you can probably safely do everything else. So it's either a doctor or a nuclear physicist or someone. So yeah, this is the idea for the attestation framework, and this is going to be one of the first things we build. It's going to be using the EAS thing. Ideally, we want some ZK on this, just because privacy by default, I think, is a reasonable thing. And then the idea is this mechanism could scale to other things. So we will probably be looking at doing some things in synthetic biology soon, maybe neurotech, some of the other focus areas where we can give an actual curriculum and have people trained in the science who began as non-scientists, and then ideally they can go to work for a DAO. I can stop there for a couple of minutes if anyone's got any questions. No.
Mentoring or what? I mean, in terms of real learning, what you know.
When you say main idea, what do you mean?
I mean, I have quite used with education, and I have classes of 200 students.
Yeah.
And the reason why I have classes of 200 students is that I cannot do one-to-one with each of the 200. And of course, it will be infinitely better for each of them. It's impossible. No?
Yeah.
So this is the kind of scale that we have normally. No?
It doesn't require one-to-one. It's one. The facilitator is the only one, is the knowledge expert, and there will be 10 fellows. I just put 6 just because it was easier for this diagram. And you don't need to do any content. Yeah, exactly. So our group's 40 people, but they'll be working in small groups of 10 just for the teaching phase. And this is just the product that the core team is building out, not the product that the fellows will be working on. This is what is coming next, if I've got time to present it. Okay. This is going to be a bit of a whistle-stop tour because this itself is normally like a 20, 30-minute presentation. One of the things we've heard multiple times today is the reproducibility crisis. And what are the reasons for the reproducibility crisis? Just shout it out. No data, yes. I think about 60% of papers have no raw data available. My personal bet is that on a large percentage of those, the raw data never existed and it was just falsified. So the current system of science, you are trusting the human, and you are trusting that the human has accurately reported that data, that they haven't falsified, they haven't tampered with equipment, that they haven't, used an AI to generate a large authentic looking data set, or even p-hack, which is when you run multiple statistical analyses on the same data until you hit a signal, and that's not a good way of doing science. So the problem is the human, that we are having to trust the human. And as we go forward, we're going to see a big change in how science is conducted. A lot of science is going to be machine-to-machine automated. It could be AI-driven. We are going to see an emergence of a creator economy of scientists where people are doing work outside of a lab setting, outside of an industrial setting. And really at the heart of a lot of this is the IoT device. So an IoT device can be anything from a sensor in a wet lab to a wearable to an EEG machine. And these are the points where the data is being generated. So that is the source of truth. And we need to figure out a way of getting that source of truth on-chain or whichever mechanism, because that's the only thing that you can actually trust. I also do think the future of research is just going to be machine-to-machine, autonomously recording on-chain with very little human involvement. So this is kind of what we are building for. So causality network, and just to back up a bit, this is the thing that the fellows will most likely be working on. Not definitely, because it comes to a public community vote. The fellows vote, the community votes. But this was the idea me and my co-founder have spent the last few months validating. So it's a protocol that runs on IoT devices where a secure enclave or another means attests to the data's validity. So then what you have at the end is a data set that has proof of why it's authentic. And this doesn't really exist in science right now. And in 10 years, this is going to be a massive problem because AI is going to be able to generate incredibly authentic looking sets, so you are not going to know what's real. So we need a mechanism to figure out if the data is authentic or not, and this is our kind of idea at this. So there is a mechanism that attests that the data is authentic. Remember the current system, this mechanism of attesting is just a human saying, yeah, this is okay. On this one, we want a machine-derived layer of trust. That's probably going to be a secure enclave, maybe something else, I don't know. And you can have a ZK proof of your data, so you don't reveal any of your data, but you can show this data set was authenticated via this mechanism. Again, any questions right here? I see some noddings, I see some shaking of heads. Anything? No? And the long-term idea was that you can have marketplaces being built on top of it. You can have a variety of use cases. So use cases, at least initially, would be biohackers, labs outside of the West, other deep-in projects. And you can build both commercial data marketplaces on top of it. AI agents would run on top of it. You can have prediction markets on top of it, etc. Don't think any of this is relevant. That's the team. So that's me, co-founder, and the blockchain engineer.
What kind of devices are you thinking of? Like, I work with
Yeah.
Like, one thing is you have, like a secure enclave, let's say, like a security chip on that, and the other way is like, let's say, hashing the data when it gets through a phone. That's what we were doing at IFX at some point when I used to work there. What's on your mind? Because there are two different problems.
So in terms of how data is verified, I'm not technical, so I'm relying on what the other people are telling me, but the way I see it is that you could think of maybe there's 10 levels of data authentication. Level 0 is just the human says so. Level 2 and 3 might be these secure enclaves or hashes, which aren't, they're not 100%. Level 5 might be, something embedded in the CPU, some fully homomorphic encryption, and then the other stuff we probably haven't even discovered yet. So that's just how my mental model for how I envision this working. But I will definitely chat to you because I didn't realize you used to work at IOTX.
Yeah, what about the parsing of the data? You're looking at a specific research that's taking data from an Aura, from a Pipit, from
a correct. So we're starting with neurotech stuff just because you can buy open source devices, you can pair a secure enclave onto it, and then you can produce data sets that don't exist on the marketplace right now. Like I said, it's not confirmed this project is going ahead. I think the fellows will end up working on this because I think it's something that is a massive problem in science, and trying to tackle an ambitious goal to me makes more sense than doing something else.